Hey there, this is Jacob from RC, here today wielding our new state-of-the-art code retriever models. So let's dive in and see exactly what these code retriever models are. So what we did is we trained code retrievers particularly tailored for Code LLaMA. So you can use these with any of your Code LLaMA retrieval augmented generation routines. And even more important than that, we open sourced the training routines to what we did in this training so you can retrain this on your own code base and for your own coding languages. So what we did here is we focused on the Python coding language. What we did there was we went through for the passage docs for the doc strings in Python functions, and we generated Q&A pairs off of those doc strings. And then that allowed us to embed the Python snippet below that in an embedding that was more rich than the original base embedding. So let's dive in a little bit into the research of what we did. So we tried a few different things. So we tried training sentence transformers, which is a lighter version of what we released today. And we also trained Code LLaMA itself with an autoregressive feature extraction, where we're using the last token in the sequence of the model to grab the embedding out of. And so here's a little bit about what we did. So when we gathered the data, what we did was like I said, we looked at that doc string, we generated the query pairs, and then we used those pairs for contrastive loss training. And here's a bit about the results that we found. So you can dive in a little bit more on this table here. But what we did is we trained the small sentence transformers. And here we can see training, we get about a 5% increase in hit rate. And then in the large ones, we're seeing about similar 5%. And then the key winner is this Code LLaMA autoregressive retriever itself, which is a little bit larger of a model with larger embedding dimension. But that is also open sourced for you as well. So let's go ahead and dive in right into using these things. So here's some code where you can actually load the Code LLaMA model for sentence embedding here in our retrieval model out of our DALM framework. And here you can see, here we'll actually load the BGE code retriever, which is a little bit smaller, runs faster, and will save your GPUs a little bit of heartache. And so that's what I was running in the notebook there. And then even better yet, you can train your own code retrievers here with the DALM repo. So here's the training routines. You'll need obviously a training CSV, and you'll have to go through. We have some automatic generation scripts within the DALM repository that you can use, but also you can bring your own QA pairs to use DALM. And you can use DALM outside of code as well. This works for any domain where you want to be training a retrieval augmented generation model. And yeah, so here's the training scripts, and then you can also evaluate your retrievers after that. And then even greater here, we have hosted this model within our platform. So here you can send queries at it, and you can see it generating with Code LLaMA and retrieving the passages. So here I asked it from the Bodo library for AWS how to link an S3 upload to an SQS queue, and it's grabbing the passages out of the Bodo library here related to SQS and S3, and then synthesizing a response. So that's a little bit of a demo of this actually works in production. And then let's see, what else do I have here? So yeah, in summary, you can use these retrievers. So I'll link this demo notebook here to embed your Python code pre-trained, or you can train them on your own repositories with our training routines. And you can always try out the RC platform to see how these work in production and at scale. So thanks for watching today. And this is a good little demo of the new code retrievers we just released. Happy retrieval and happy generation.